Assalamu alaikum dear students. This is our next problem. Problem having been chosen from the same book Modern Physics by Stephen T. Thornton and Andrew Rex. As usual, we first come to its statement. Okay, what fraction of 5 million electron volt alpha particles will be scattered through angles greater than 8 degree from a gold foil? Within bracket it is given that information is given that atomic number Z is equal to 79, density is equal to 19.3 gram per centimeter cube, gram per cubic centimeter, okay, of thickness 10 raised to the power minus 8 meter. Okay, so dear students, in this problem kinetic energy will be 5 million electron volt or 5 into 10 raised to the power 6 electron volt. Okay, moreover, because interaction is in between alpha particles and gold foil, so atomic number of gold is given as 79, while we know that number of protons in alpha particles, that is helium nucleus, are 2. Okay, so here 2 and 79, these two numbers are involved, number of protons. Okay, moreover density of gold is given, moreover angle of scattering is also given 8 degree, and we know that angle is always taken in half, that is theta by 2, it will be 4 degree. Moreover thickness is 10 raised to the power minus 8 meter. Okay, here T is minus 8 meter. Now we move to its solution, but before going to its solution in a proper manner, we will have a minute introduction about the terms involved. Okay, we are dealing with the alpha particles and gold, so some information about alpha particles, gold and atomic number and mass number should be had. Okay, so alpha particles, about alpha particles, it is sufficient to say that alpha particles, also called alpha rays or alpha radiation, consist of 2 protons and 2 neutrons bound together in a particle identical to a helium-4 nucleus. Similarly, in about gold, it is sufficient to say that gold is a chemical element. It has a symbol Au from Latin aurum, gold. Okay, in Latin gold might be called aurum in some ancient period, or perhaps till now, and atomic number 79. Okay, so about gold it is enough. Now we move towards the atomic number. Atomic number or proton number, symbol Z, the number of protons in the nucleus of an atom. The atomic number is equal to the number of electrons orbiting the nucleus in a neutral atom. Okay, dear students, we know that an atom is basically neutral, so it can be neutral only when and we also know that charge on proton and electron is exactly equal, only it is of opposite sign. Okay, so number of protons must be equal to number of electrons, otherwise neutrality cannot exist. Okay, nucleon number or mass number, its symbol is A, the number of nucleons in an atomic nucleus of a particular nuclide. Now dear students, we are going to define density. Okay, because because the concept of density is also involved in this problem. Okay, density. Dear students, this snapshot, I think this snapshot has been chosen from the book fundamentals, holiday Resnick Gerald Walker. Okay, okay. Density. The density rho of any material is defined as the material's mass per unit volume. Rho is equal to delta M over delta V. This expression has been given a particular equation number, okay, as per arrangement of the book, okay. Then it is described that usually where a material sample is much larger than atomic dimensions, we can write the above equation or above expression as rho equal to M over V, okay. So what does it mean? It means that in place of delta M we can take simply M, and in place of delta V we can take simply V, okay. Delta means change, okay, basically. That is, delta M usually means M2 minus M1 and delta V means V2 minus V1, but here situation is described in which we can just take M by V, okay. Next table is given in which densities of some common substances at standard temperature 0 degree centigrade and pressure, atmospheric pressure, are given, okay. Here, dear students, we can see that this gold is given 19.3 into 10 raised to the power 3. Its units are written above, rho kilogram per meter cube, okay. Dear students, actually we do not need this value. This value is given in the statement, but purpose of including this table in this problem in this video is just to develop a confidence that even if in the problem this value is not given, we can take this value from such tables. Such tables are a compulsory part of every book of general physics, okay. Every book of general physics definitely contains such a table, okay. So here 1 2 3 4 5 6 7 8 9 10, at row number 10 on left column, row number 10 is about gold. It is given 19.3 into 10 raised to the power 3 kilogram per meter cube, okay. We do not need to go to right column, okay, because our requirement has been fulfilled at row number 10 of first column, okay. Now we are going to define Avogadro's number, okay. Avogadro's number, 1 mole of a substance contains Na, where A is written as a subscript of N. This is called Avogadro's number. Elementary units, usually atoms or molecules, where Na, capital N, capital A, where capital A is written as a subscript of capital N, is found experimentally to be Na equal to 6.02 into 10 raised to the power 23 mole inverse, okay. That is 1 over mole, Avogadro's number. This is the definition of Avogadro's number. We move a step forward. 1 molar mass capital M of any substance is the mass of 1 mole of the substance. It is related to the mass M of the individual molecules of the substance by capital M is equal to small m into capital N, capital A, where capital A is written as a subscript of N. The number of moles N contained in a sample of mass M SAM, that is mass of sample consisting of capital N molecules, is given by small n is equal to capital N over capital Na, where capital A is written as a subscript of capital N, is equal to M SAM, that is mass of the sample, divided by capital M is equal to M SAM over small m into capital N, capital A, where capital A is written as a subscript of capital N. This was about Avogadro's number and molar mass. Okay, now dear students, in the next snapshot we have taken a small piece of a very large table which is compulsorily included in every general physics book. Okay, actually dear students, this table is basically about chemical properties of elements. Okay, in this table atomic number, mass number, configuration, etc., and many things are given, and this table has so many columns, but we have taken just a small piece of that table in which one, 2, 3, 4, 5, 6, only 6 columns are included, and from here we will get some information about gold. Okay, okay, dear students, here this is in accordance with the Z atomic number of protons from 1 to where it varies from 1 to so on. Okay, so we have taken only that piece of that table in which 79 is included. Okay, 79 AU aurum, gold. Okay, gold is actually its ordinary name, while its chemical name is aurum. So in accordance with aurum, it is AU, capital A, small u. Okay, its electronic configuration is this, but for the time being we are not concerned with this. While its density is 19.3 and its units are given in the upper part of the this this gram per centimeter cube. Okay, next gram per mole. Okay, next dear students, we see that where 79 is given and other value is given 196.96655. okay, this is, what is this? This is molar mass, m gram per mole. Okay, so dear students, in this problem these two values will be used. Okay, one is given in the statement while other is given in this table, and it is also a fixed value. This value is like a table of constants, so we can take it also from some other similar tables. Okay, now dear students, 1 mole gold is equal to 196.96655 gram. This value. Okay, this value 196.96655. 1 mole gold is equal to 196.96655 gram. Molar mass of aurum or gold is equal to 196.96655 gram per mole. Atomic mass of gold is equal to 196.97 atomic mass unit issue. Okay, because here students we can convert it in 97, because the digit next to 6 is greater than half, that is 5. So so we can also write it as 196.97 atomic mass unit issue. Okay, next, in next slide, dear students, a table of physical constants is given. This is a very comprehensive table and we can choose that value which is needed for the solution of this problem. Okay, next snapshot is about impact parameter and fraction. Okay, next snapshot, actually next two snapshots are exactly same, only different books have been consulted. That is why there is a minor change in the description of these expressions. Okay, scattering impact parameter B is equal to Z is small z capital Z over 2 capital K into E square over 4 pi epsilon naught into cot theta by 2. Okay, dear students, here actually K is at kinetic energy, Z is the number of protons or atomic number of one element and other element, and this is elementary electronic charge which is given in that table. Okay, in this table, E is given. E is also given. Moreover, value of epsilon naught is also given somewhere. Mm, Anyhow, we do not need to put the value of E or epsilon naught here. Direct value of E square over 4 by epsilon naught is given as 1.440 electron volt into nanometer or million electron volt into femtometer. Okay, so moreover, value of epsilon naught is also given in, but perhaps in this table it is not. For that purpose, we need some other table. Okay. Anyhow, vector parameter fraction scattered at angles greater than theta. Okay. Fraction greater than theta is equal to pi t n t pi b square. N t pi b square. Here b is the impact parameter. This n is the number, pi is the 22 by 7 equal to 3.14 and t is the thickness. Okay, this snapshot is alternatively given in this form. Okay, Rutherford scattering impact parameter b is equal to small k q alpha into capital Q into m alpha mass of the alpha particle into v square into cot theta by 2. Actually, dear students, here small k denotes 1 over 4 pi epsilon naught. Okay, this portion 1 over 4 pi epsilon naught, in place of this small k has been used, while in place of capital K, that is kinetic energy, m alpha into v square, mv square, half mv square, that is used. Okay, moreover, z in place of e square, one is charge of the alpha particle and other is the other charge denoted by capital Q. Okay, so these two are charges in place of e square. Remaining cot theta by 2 is the same. Okay, scattered fraction f is equal to pi b square nt for a scattering foil with n nuclei per unit volume. Okay, n is the nuclei per unit volume, n is the nuclei per unit volume, and thickness is t is the thickness, thickness, angle is the theta is angle of scattering, b is impact parameter, and so on. Okay, yes students, now we are going to use these two snapshots in a regular manner in our problem. We can adjust these things as the relation between the impact parameter b and scattering angle theta for Coulomb scattering is small b is equal to z1 z2 e square over 8 pi epsilon naught capital K into cot theta by 2, equation number 1. Okay, here K is kinetic energy. Okay, dear students, now scattered fraction f for a scattering foil with n nuclei per unit volume and thickness t is given by f is equal to pi b square nt, equation number 2. Now what we will do, we will use this value of b from equation number 1 in equation number 2, and we will get the value of scattered fraction. Okay, so we say that by using equation number 1 in equation number 2, we have scattered fraction f becomes equal to pi into n into 2 into z1 z2 e square. Okay, so dear students, actually this mistake was also repeated in the previous problem, and it is here once again. It could not be rectified, and it is again appearing in this problem. Okay, dear students, actually because impact parameter b is in square. Okay, that is why cot theta by 2 has been taken in square. So this value is also taken in square, but mistake which could not be rectified in previous problem is still existing. Okay, because in preparing these lectures, copy paste facility is availed again and again. Okay, what I have said that in preparing these lectures in word format using math type, facility of copy paste is utilized again and again, and if unfortunately some mistake is involved, then until and unless that mistake is not rectified, it repeats itself. Okay, so uh, I mean to say that this portion is also in square, like cot square theta by 2. This factor is also in square, z1 z2 e square over 8 pi epsilon naught capital K. This whole is also in square. Okay, also now dear students, this is the formula for n. About n we have said that n is the we have said that about n is the n nuclei per unit volume, n nuclei per unit volume, n nuclei per unit volume, n nuclei per unit volume. Now for formula for small n is equal to rho into capital N capital A, where capital A is written as a subscript of capital N, into capital N into capital M, where capital M is written as a subscript of capital M, divided by capital M small g, where small g is written as a subscript of capital M. This equation is given next number, that is equation number 4, where rho is the density in gram per centimeter cube. Okay, capital N capital A, where capital A is written as a subscript of capital N, is the Avogadro's number. Okay, molecules per mole. We have prior to this we have already studied the definition of density. Similarly, we have also studied the definition of Avogadro's number. N capital M, where capital M is written as a subscript of capital M, is the number of atoms molecule, and capital M small g, where small g is written as a subscript of capital M, is the gram molecular weight, g over mole. Okay, dear students, now using rho is equal to 19.3 gram per centimeter cube, this value is given in the statement. Okay, Na Avogadro's number is equal to this is we know that from definition of Avogadro's number, mole over Nm is equal to 1 atom oblique molecule over molecule. Okay, this is the definition of this. Okay, in that equation we are using these values. Mg is equal to 197 gram per mole. Okay, actually dear students, this 196.96655, here we are taking it as 197. Okay, 197 here. Okay, yes students, using these values. Okay, this value is given in the statement, while this value is given in the snapshot which we have taken a small piece of the very large table in which Z79 about gold aurum was shown. Okay, so we will put all these values in above equation. In equation number 4 we get small n is equal to 19.3 gram per centimeter cube into 6.02 into 10 to the power 3 molecules per mole into 1 atom per molecule divided by 197 gram per mole. Okay, here what factors will be cancelled? Molecules will be cancelled with molecule, gram will be cancelled with gram. Anyhow, we see what after simplification this becomes equal to, n becomes equal to 0.5898 into 10 raised to the power 23 atoms per centimeter cube. Okay, then this becomes equal to this into this atoms per, in place of centimeter we are now going to convert it into meter. We know that centi means hundredth part, hundredth part. Okay, 1 meter is equal to 100 centimeter. Okay, so when we will convert centimeter into meter, then we will have to take a reverse calculation, that is to say minus 1 over 100 is equal to 0.01 meter, and when its cube will be taken, then it will be 10 raised to the power minus 6. It will become 10 raised to the power minus 6. Okay, this is just simplification. We need not to explain these minor steps. Okay, because dear students, centimeter cube when converted into meter cube, then it will become 10 raised to the power minus 6 meter. Okay, because 100 centimeter is equal to 1 meter. Okay, so when 0.01 taken will be multiplied 3 times, then it will become 10 raised to the power minus 6. Okay, so this 10 raised to the power minus 6 will be shifted to a numerator, and it will add in this value. It will become 10 raised to the power 29. Okay, so our n becomes equal to 0.5898 into 10 raised to the power 29 atoms per meter cube. Okay, to this extent our answer is 100% correct. However, just as a fashion, or just as a good practice, we convert it in this form. That is to say, instead of 0.5898, we convert it in 5.898. Okay, if we do so, then this 29 will be reduced to 28, because we are shifting decimal one step ahead. It means we are dividing it by 10. So it will become 10 raised to the power 28 atoms per meter cube. Okay, so this is the value of n has become equal to 5.898 into 10 raised to the power 28 atoms per meter cube. Now, using Z1 equal to 2, Z2 equal to Z1, this is alpha particle, 2 protons in a helium nucleus 4, that is alpha particle. This is gold. Theta angle is given as 8 degree, and this value we have calculated in our previous step. Okay, 5.898 into 10 raised to the power 28 meter inverse cube. Okay, because it was 1 over meter cube, so meter inverse cube, meter raised to the power minus 3. Okay, moreover, value of this is given in this from table, which is included in our snapshots. Okay, moreover, pi, which is equal to 22 by 3 is equal to, is taken as 3.14, and kinetic energy K is given in statement 5 million electron volt, or 5 into 10 raised to the power 6 electron volt. Thickness T is also given in the statement, which is 10 raised to the power minus 8 meter. Okay, now we will use all these values in equation number 3. Okay, first we had utilized equation number 4 just to find out the value of n. Now we are utilizing equation number 3. Okay, in order to find the scattered fraction. Okay, so scattered fraction F becomes equal to, this is pi, this is the value of n, this is the value of T, thickness, and this is the value of Z1, Z2 into E square over 4 pi epsilon naught. Okay, this is the value of that, and this is the value of kinetic energy 5 million electron volt, and this is the 2, this 2 is a formula. Okay, this 2 is 2 protons of alpha, but this 2 is just a formula. Okay, these 2 will be cancelled out, but it is better to explain that this 2 means 2 protons of alpha particles, but this 2 is included in the formula. Okay, moreover, cot square theta is, because 8 degree, so theta by 2 will become a cot 4 degree, And next we will just simplify, just simplification, dear students. Value of cot 4 degree is 14.3. Okay, I have taken this value of cot 4 degree from online calculator, online Google calculator. Okay, you can take this value from some other source also. Okay, I have used the quickest and easiest method, okay, available. Okay, dear students, just simplification, nothing else, just simplification. After simplifying, we get the scattered fraction f equal to, scattered fraction f becomes equal to 1960079.84 into 10 raised to the power minus 10. This becomes equal to 0.19 into 10 raised to the power minus 3. Okay, to this extent our answer is 100% correct, but just as a fashion or as a matter of facility, or as a matter of convenience, we are converting it into 1.96. When we will do so, then it will become, instead of 10 raised to the power minus 3, it will become 10 raised to the power minus 4, because we are shifting decimal one step ahead, so it will be divided by 10, and hence 10 raised to the power minus 3 will become 10 raised to the power minus 4, and hence scatter fraction f has become finally equal to 1.96 into 10 raised to the power minus 4. This is the end of our problem. This is the end of our video. Till next video, Allah Hafiz.